Okay, welcome back everyone. This is chapter 2.1, rectangular coordinates and graphs. So first of all, we're going to talk about something called an ordered pair. This consists of two components, which are going to be written inside parentheses. So you might see an ordered pair written like this, x comma y. So what we're called the x coordinate is going to go first before the comma. The y coordinate is going to come second. And this might look something like 2 comma 1. You can have negative numbers, negative 1 comma 1. You could have decimals. You could have something like 0 comma 0. We're going to talk about what this is. This is called the origin on our coordinate plane. And you can even have fractions as coordinates. So the way this rectangular coordinate system works, on the horizontal axis, we've got what's called the x-axis. Okay, so this is running from right to left. The left side is going to be negative x values. The right side is going to be positive x values. In the vertical dimension, we've got the y-axis. Positive y values are up above the x-axis. Negative y values are going to be down below the x-axis. And the origin is our central point here. That's where the x and y axes intersect. Okay. We've got our quadrants. Okay, so they're going counterclockwise. We start with quadrant 1. This is when both x and y are positive. Then you've got quadrant 2. This is where we've got a negative x, but we've got positive y. Quadrant 3, this is where both x and y are negative. And quadrant 4, so here you've got a positive x and a negative y. Okay? And your coordinates are written like this. So we've got a comma b. A is telling us we got this point here that we're considering, right? So A is telling us how far we are from the origin, left or right. That's the x value. And B is just telling us how far we are from the origin, up or down. Okay, so in this case, we went left by A, up by B. And that coordinate point is A comma B. Okay, so let's look at a couple of examples. So of course, we've got the origin here in pink, 0 comma 0. You've got this example point in red, 2 comma 1. So we went 2 to the right and 1 up. You've got negative 4 comma 3. So we went 4 to the left and up 3. This is over here in quadrant 2. We've got negative 3 comma negative 5 in green. So we went negative, so 3 to the left and 5 down. That's negative 3 comma negative 5. And the last one in yellow, you went 2 to the right and 3 down. Whoops, that one's plotted at negative 4, so we're going to bump that point up over here a little bit. Okay, so we went 2 to the right and 3 down, so 2 comma negative 3. Okay, so these are some examples of points that you might come across written as coordinate pairs. Okay, now what can we do with this information? Well, we've got something called the distance formula. Using the coordinates of any of these 2 points, we can calculate the distance between them. Okay, and that is going to be given by this formula. So we've got the square root of x2 minus x1, that difference squared, plus, in parentheses, y2 minus y1, that difference squared. Okay, so let's see how this looks. So let's say, for example, we want to find the distance between points A and B here. And we're given the points 2 comma 1 and negative 3 comma negative 5. So this is our point A over here in red. This is our point B over here in blue. And we will find this green distance over here. How far are these 2 points away from each other? So we go to our formula. Now, I'm going to use here the red point as, say, point 1, and the blue point as point 2. it doesn't matter what order you put these in, as long as you're consistent. Okay? So we want to take the x1 and y1 from the same coordinate pair. We want to take x2 and y2 from the same coordinate pair. Okay? So I'm doing it like this. So my x1 is going to be the value 2. My x2 is going to be the value -3. All right, so in my first parentheses here, inside of my square root, I've got -3 minus 2, that difference squared. And for the second set of parentheses, well, I've got my y2 over here, which is -5. I've got my y1 over here, which is 1. Okay, so we're going to do -5 minus 1 squared in our second set of parentheses. So we find those differences. We've got -5 squared plus -6 squared. Those, of course, are both going to come out as positive quantities. Any negative values squared are still positive. So we get the square root of 25 plus 36. That comes out to the square root of 61. That doesn't reduce in any nice way. We cannot take away any, or we can't factor out any sort of perfect squares from that. So we just leave it. So our distance between these 2 points is the square root of 61. Okay, and you can do this with any pair of points. You can do this between multiple points if we're considering some shape like a triangle or a square or something like that. This is a very valuable formula, very useful formula. Next, we've got the midpoint formula. So now the coordinates of the midpoint of some sort of line segment. So a line segment is just, we've got 2 points. We're connecting them with a line. A midpoint is something that is going to fall in right in the middle between those 2 points, those 2 endpoints of your line segment. Okay, so we've got x1, y1, and x2, y2 as our endpoints. This formula is going to be given by m is equal to, now we've got a coordinate pair, right? The midpoint is just going to be another coordinate. x1 plus x2 over 2 is your x value for your midpoint. y1 plus y2 over 2 is the y value of your midpoint, okay? So it's really like you're just taking the average of the x values and the average of the y values, and that's how you're going to get the coordinates for your midpoint. So let's look at an example. Find the midpoint of the line segment from 8, -4 to -6, 1. So we throw those into our formulas. We take the x value from the first one. We take the x value from the second one. We calculate their average. 8 plus -6 divided by 2. We do the same exact thing for the y values. We get -4. We get 1. And take their average. Add them and divide by 2. For our first point, we're going to get 8 plus -6, which is just 2. 2 divided by 2 is 1. For the second one, we're going to get -4 plus 1, which will be -3. -3 divided by 2. We're going to leave that as a fraction. It's not going to simplify nicely. Now we can go ahead and let's go back to our coordinate plane. Let's plot these. Let's see how this looks. Okay, so we've got one endpoint here in red, -6, 1. We've got our second endpoint here, 8, -4. We've got the line segment, so we're connecting these. The difference between a line segment and a line, well, a line is just going to go on infinitely on either side. So we just draw our arrows. A line segment is going to stop at our endpoints. Okay. So our midpoint is directly in the middle. It's 1, -3/2, which is approximately -1.5. Okay, so that holds up visually as well. This point M is going to be right in between these two midpoints. Okay, next we can talk about solutions to equations. So solution to an equation is simply an ordered pair or coordinate pair that makes that equation true. Okay, so it's some combination of x and y values that works. Okay, so an equation is just going to be some sort of relationship between x and y. And we're looking for what coordinate pair, what combination of x and y is going to make that relationship true. So the first one says find the solution with y equals 3 to the following equation. So we've got y is equal to 4x minus 1. Okay, so we've got y is equal to 3. We're trying to figure out what x value makes this relationship hold up with y equals 3. We substitute 3 in for y, and let's isolate x. So we add 1 to both sides. We got 4 is equal to 4x. Divide both sides by 4, get that x by itself. X is going to be equal to 1. So the coordinate pair, the solution that makes this true, one of the solutions that makes this true is 1, 3, right? There are infinitely many solutions to this, right? If we were given, say, x is equal to 0, we could plug that in. And if x is equal to 0, then y is going to come out to -1. So 0, -1 is another solution to this equation. We can do this for any x value or any y value that you choose, okay? So this is just one example of a solution. Let's try this again. So now this time we're given the x value. Find the solution with x equals 1 to the following equation. Different equation this time. X is equal to the square root of y minus 1. Okay, so 1 is going to be equal to the square root of y minus 1. We can square both sides to undo this square root. Well, 1 squared is still just 1. And then on the right side, we get y minus 1. We add 1 to both sides, y is equal to 2. So our solution in this case is going to be 1, 2. And again, there are infinitely many solutions to this. As long as we can, again, in the real number system, we want the square root, the number underneath the square root to be positive. So, but there's still infinitely many values of y that would make that true, and infinitely many values of x that go with those, right? So that pair with those values of y. So in this case, we're going to complete a table of solutions in part C for the equation y is equal to x squared minus 4. So these are the values they give us. The x values are running from -2 up to 2, so -2, -1, 0, 1, and 2. They've given us the y values for -2 and for 0. We're going to find the remaining 3 solutions over here. Okay, so this table consists of 5 solutions. They've given us 2. We're going to find the other 3. So we're going to plug in, first of all, -1 for x. We'll have -1 squared minus 4, which will just be 1 minus 4, which comes out to -3. So that's our first solution. -1, -3. Our second one, we're going to plug in now +1 in for x. 1 squared minus 4, it's going to be the same exact thing. These both come out to +1, so 1 minus 4. This will also be -3. So the second solution that we found is 1, -3. And lastly, we're going to plug in 2 for x. 2 squared minus 4 is going to give us 4 minus 4, which gives us 0. Okay, so that's our table. If we were to write these as ordered pairs, we would just put them in parentheses. We would maintain that order, okay? And then once we have these, we can go ahead and plot them if we like. And as we're going to see in a second, we can draw graphs and things like that for these. Okay. So graphing equations now. Well, if we've got our tables, we've got our points, we can go ahead and plot the shape. What does this look like? So for part A, let's use 2 points to plot the following equation. Y is equal to 4x minus 1. Okay, so it's that same line from before. Let's see how this shape works. Okay, so we've got a table here. First, let's just use 0 for x and 1 for x. Let's plug this in each case and see what we get for y. So if we plug in 0 for x, bring it 0 minus 1, y is equal to -1. 0, -1. It's our first point. We do the same thing with x is equal to 1, and we're going to get y is equal to 3. 4 times 1 minus 1. 4 minus 1 is 3. Okay, so our points here are 0, comma, negative 1, and 1, comma, 3. So we come over to our rectangular coordinate plane. 1, comma, 3 is going to be this red dot up here. We went 1 right and 3 up. Let me do that in different colors. It's a little bit easier to see. So we went 1 right and 3 up. And our second point is going to be 0, comma, negative 1. So for 0, comma, negative 1, we're not going anywhere left or right. We're starting at the origin. We don't go anywhere left or right. We just have to go 1 down. So that's 0, comma, negative 1. That's this point here. When we connect these, we get a line. So this is a line, not a line segment. This is going to go off in either direction forever. So we just denote that with arrows. Okay, so for a line or a linear shape, you only ever need 2 points to graph that. Part B says, use 5 points to plot the following equation. Now this equation says y is equal to x squared minus 4, which now you may recognize, because it has a square in it, this is quadratic. Okay, this is no longer a linear equation. So let's see what kind of shape a quadratic equation is going to give us. So we can use our table again. Let's say we're going to use the x values -2, -1, 0, 1, 2. Okay, so these are the same values we used in our table earlier. Let's do the same thing here. So we're going to get, for our first point, -2, comma, 0. For the second one, -1, comma, -3. 0, comma, -4. 1, comma, -3. And 2, comma, 0. Okay, so we just plugged in every single one of those x values, and we simplified. 4 minus 4 is going to be 0. 1 minus 4 is -3. 0 minus 4 is -4. And these two are going to be, well, symmetric to those, right? Again, we're going to have 1 minus 4, -3. 4 minus 4, 0. Okay, so we come down here. We can see our points here in the table, but this is what we're plotting, right? So we've got -2, comma, 0. So we start again with our origin. We go left 2, and then we're not going up or down because our y coordinate's here. So we're just going left 2. For our second point, we go left 1, down 3, right? That's what that -1, comma, -3 is going to be. Our next point, 0, comma, -4. So for our x, we do not go left or right. For our y, we go down 4. Then for our last 2 points, we've got 1, comma, -3. We go right 1, down 3 for that -3. The negative is a little bit covered over here. And then for our last point, 2, comma, 0, we go right 2. We do not have to go up or down for our y. And this shape, it's not the smoothest looking shape here, but the shape comes out to what's called a parabola. Okay, so it's this curved sort of shape. It might look like sort of a U shape if it's a positive facing parabola. It may also be flipped that way, facing downwards. All right, so that's a quick look at rectangular coordinates and graphing. I hope you enjoyed this video. Please make sure to like the video and subscribe to the channel for more content like this. Thank you for watching.